All right, so today's lesson we are going to be talking about functions review. So these concepts today is just going to be a review from what we did last year. So our objective is going to determine if a function is a relation or a function, and then find domain and range and evaluate functions. Okay, all things you've seen last year, but if you don't remember, that's fine. We're going to review. So let's look at the basic definition. What is a relation, or what are relations? Okay, the definition is it's a mapping between two sets, an input and an output. And mapping sounds scary, but all it says is this number goes with this number, or this thing goes with this thing. So it's an input goes with an output. That's what a mapping is, right? So an example could be when they put this into ordered pairs, right? So here the 0 goes with the -1. So the input is 0. You put in 0, you get -1. You put in 2, you get 7. You put in -1, and you get -5. Okay, so that's a relation. And ordered pairs is one way of representing that. Another would be with a table, right? So here's a table. It's the same values, right? You get put in 0, you get -1. Put in 2, you get 7. Put in -1, and you get -5. And you can do this graphically. So on a graph, they can put the dots on there to show you a relation as well, right? So you have here, here is 0, -1, 2, 7, and -1, -5. One more way of representing relations would be with a rule. A rule is an equation, right? Like y is equal to something. So in this case, what is the rule? Can you figure it out? Right? Y is equal to what? That works for all these 3 points. Now let's move on to functions. Functions are one type of relations. Okay, so if you have relations, it could be a function, it could not. But if you have a function, it is a relation. So functions are just relations, or function is a relation that each input is associated with only one output. Okay, so if you have an x, it can only give you one y. It cannot have another y with it. Okay, so that's the difference between functions and relations. And then we have to talk about domain and range. So domain is a set of all inputs. So you just list, or you write it some way to show all the inputs, all the possible x values in your function. And the range is a set of all outputs, right? So all possible y values. So let's look at these ordered pairs here that we had earlier. What are our domain and range? So the domain would be the set of all x's. So here my set would be the value 0, 2, and -1. And I didn't put them in order either, right? But it doesn't really matter. So the range, of course, would be -1, 7, and -5, all my y's. Okay. Here, I have another example where it's not even numbers, right? Functions don't have to be just numbers. It can be anything to anything. So here, we have the function of the states mapping to the number of their representatives. So here, my domain would be all the states, right? So my domain would be Alaska, Arizona, California, Colorado, and so on. These are the values in my domain. And my range, of course, would be the numbers of representatives in each state. Let's look again here on the graph. We have a few points. So if you're looking for a domain of this graph, you have to look at all the x values in the function, right? This function has a point here. So what is that x? That would be part of my domain. I look at this one. What is that x? That's part of my domain, right? So here, my x would be -1. Here is 2. Here's 3. And here's 4. Now the range, I would have to look at the y values. So the y values here is -2, -1, 0, and 2. Okay. This point, the y value is -2. At this point, the y value is -1. At this point, the y value is 0. And this point, the y value is at 2. That's my range. Now we have to decide, if they give you something, you have to decide whether it's a function or not, or is it even a relation, right? So here's how we do it. First one, they give you a bunch of ordered pair. Okay, is it a relation? Yeah, because it's a mapping between the input and the output, right? So here's an input, you got an output. Here's an input, you get an output. This input gets you an output. So it is a relation. Now, is it a function? You have to decide, does every x only give you one y? Let's look at this 4. This 4 is an x. It gives you this y. Does it give you any other y? Is there another 4 that gives you another y? Yes, this one right here. I have 4 that gives you 1, and 4 gives you 9. See, this 4 gives you 1 and 9. You can't have that. You can't have the same x giving you different y's. So it is not a function. Okay? Next one. Here, I have 3, 5, -3, 5, 0, 0. All right, so it is a relation, right? Because you have input and output. Every input has an output. Okay, it is really a relation. It is a function, yes. You might have thought that this is not a function because you see the same 5 here, but that doesn't matter because they are given by different x's, right? It is not a function if the same x gives you different y's. If you have different x's give you the same y, is fine. Okay, make sure you know that distinction. As long as the x's are different, it's okay. If you have the same x, it's not okay, not a function. Here, I have one ordered pair. It is still a relation because you have an input for an output for an input. It is a function because the 7 gives you one output, which is another 7, but that's fine. As long as the 7 doesn't give you another number, then that's a function. Okay. Here I have a 6, and it's not a relation because I don't even know if it's an input or an output. There's no mapping here, so it's not a relation. So it cannot be a function either, right? Here is that the table we had earlier. So these are my x values here, and this 0 gives me this 2 gives me this -1 gives me this. So every x only gives you one y, right? Even though these two different x's give you the same y, it doesn't matter. As long as the x's are different, it is a function. Here's this one. Here I have 0 gives me -1, and 0 gives me -5. That's not a function because the same x gives a different y, not a function. Relation, yes. Function, no. All right, so they could give you equations and ask you to decide if it's a function. And the best thing to do is to solve for y. Like this equation here, it's already in y equal form, right? Y is already solved. Now you have to, this is the analysis part, right? You have to analyze this equation and think, if I put in a value for x, am I going to get the same, am I going to get one y, or am I going to get different y values, right? Because you can't have just one x giving you more than one y. Here, if I put in a value for x, like if I put in 3 for x, I get 3 times 3 is 9 minus 2 is 7. 3 gives me 7. It cannot give me any other number. So I can't have different y values. So this is a function, right? As long as you put in an x and you only get one y, then it's a function. Here's another. And looking at this is really hard. So I'm going to solve for y, right? I'm going to solve for what y is equal to. So here, oh God, you already know it's not a function, but here, why is that? So I'm going to subtract negative x squared from both sides. So y squared is equal to 1 minus x squared, and I'm going to square root both sides. So I get y is equal to plus or minus square root of 1 minus x squared. Now here, as you can see already, it's a plus and minus, right? What value I put in for x, whatever value I put in for x, I'm going to get two values for y, a positive and a negative value. So I get two different y's for each x. So it is not a function. Here, x is equal to y cubed. I'm going to solve for y. So y is equal to cube root of x. And the cube root is different from the square root because cube root does not give you a plus and a minus, right? Because a cube root gives you only one value. So if I put an x in, I get only one value for y. Like if I put in 27 for x, I get just positive 3, not negative 3. So I get only one value for y. So it is a function. All right, the last bit of this is going to be for evaluating. So here's f of x, and they're going to ask you to solve for f of something, like f of 0. All it means is if they give you x, if they give me a thing, I want to take that thing and square it, and then plus 2. So whatever that thing is, I want to take that, square it, plus 2, right? So here, I take that 0, I square it, I plus 2. That just gives me f of 0 is equal to 2. Remember, the x can be anything. It can be like a box. It can be like a cup. It can be like whatever. Like if you give me like a hammer, I'm going to take that hammer, I'm going to square that hammer up, and then I'm going to add 2 to it. I don't know how to square a hammer really, but that's what I would do, right? So the x is just a placeholder. Think of it like that. You can put anything in for x. f of 0 means that if you put 0 in, what do you get using this rule? And here I have f of x plus 1. So instead of x now, I take this whole thing and I square it and I add 2. Okay? So x plus 1 squared plus 2. Remember, put parentheses around whatever you're putting in. Okay? Put parentheses around them because you're taking the whole thing, squaring it. And that just gives me x squared plus 2x plus 1, and then plus a 2 in the back. That gives me x squared plus 2x plus 3. Here is f of x plus h. Doesn't really matter. You can give me a hammer, I can do it. So I can do x plus h, right? As long as I take x plus h, square it, then plus 2. So here is x plus h squared plus 2, parentheses around, of course. So you use FOIL, and you get this x squared plus 2xh, or 2hx, I should have put, plus x plus h squared plus 2. That's it. Preferably, I would want to do more examples with you guys so you can see it this clearly, but I'll try to keep these videos shorter. So I'm going to stop here. But if you need extra help, extra practice, let me know because we have more for you. All right.